I lost internet. And so, sorry about that. Did you guys finish the problem we were working on?
Professor,
Yeah?
I have an emergency. I need to leave early today.
Okay, it'll be recorded.
Okay, thank you so much.
All right. So, can you guys see my screen or no?
Yes.
Yes. Okay, so did you finish this for me?
What?
We were working on the 3x plus 4 minus
Yeah, I
4.
finished it.
But
Oh.
yeah.
This one? What should you do first? Distribute the 7?
Wait, are you supposed to be sharing your screen with us?
Yeah.
Yeah.
Yeah, we can't see it.
Yeah, we can't see it.
Okay. Share screen. Share. Now can you?
Yeah. Yep.
No,
Yeah.
okay, now we're good.
Oh.
Wait.
Now you're good.
Wait, where'd this come?
Did you guys not get that one?
No.
I was right that when I lost you.
I think that's where it froze.
Okay.
It did.
All right. So I've got 7 parentheses 3y minus 5 close plus 2 parentheses 4y plus 3 close. What would you do first?
Parentheses?
Yep. Can I do anything inside parentheses? Are those like terms?
No.
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 Are those like terms? No. So what do I do if I don't have parentheses?
Distribute.
Distribute. So 7 times 3y is 21y.
21y.
7 times minus 5 is minus.
35.
Now what do I need to do back here?
Distribute the 2.
2.
Gives us plus 8
8y.
plus 6.
Yeah.
Now it's all addition and subtraction. Do I have any like terms?
Yes.
21y and 21
21y plus 8y is 29y. Minus 35 plus 6 would be minus 29.
Yes.
Yes, that one all right.
Yes.
That one's right.
I'm going to go to a new page, do some more. Next one, let's look at 3 parentheses x squared plus 2x, close parentheses, minus 7 parentheses x squared plus 6x, close parentheses. Inside parentheses, are these like terms? Can I do anything?
No.
No. Are these like terms? Can I do anything?
No.
No. So what do I do next?
Distribute the
So 3x squared plus 6x. But now this next one is a little problematic. Does everybody see that's what's in front of it is a minus 7? So I don't just
yes.
distribute the 7, I have to distribute the negative 7.
Negative 7.
So that gives me negative 7x squared minus 7 times 6 is minus 42x. That all right?
Yes.
And so now do we have some like terms?
Yes.
3x squared minus 7x squared would be minus,
4x squared.
beautiful. And plus 6 minus 42 would be
Negative 36.
Negative 40.
negative 36.
Oh.
One more, and then we'll go back to that one from the homework. All right? And that one from the homework was kind of why I pushed the due date back a little bit, because I knew we were looking at these today. 14x squared plus 5 minus brackets 7 parentheses x squared minus 2 close parentheses plus 4 close brackets. How fun does that look?
Wow.
So order of operations. Is there new things in the chat, guys? Okay. I'm going back. Inside innermost parentheses first? Can I do anything in there?
No.
No.
I
So
know.
what do I need to do to get those out of there?
Distribute.
Distribute.
So inside there, I get 7x squared minus 14. And now I've still got the plus 4. And for just a minute, I'm going to look inside there, focus inside there. That's still inside. Now, is there anything I can combine in there?
The negative 14.
4 in the 4.
What does that give us?
Negative 10. I almost said positive 10.
7x squared minus 10. And now let's throw the rest of the problem back there. 14x squared plus 5. And do you see how there's a minus sign in front of those brackets?
Yeah.
Are you folks all familiar that when there's a minus sign in front of the grouping,
You distribute it.
I have to distribute negative 1. And so the 14x squared plus 5, they're out of the parentheses. They stay as they are. But over here, I have to distribute negative 1. Negative 1 times 7x squared is
Negative
minus,
7x squared.
and negative 1 times negative 10 is
Positive 10.
10. And now, let's see. Now we've got some like terms. 14x squared minus 7x squared
Is 7x squared.
plus 5 plus 10 is
15.
plus 15.
15.
How's that one?
That's good.
Not as ugly as it looked when you first looked at it, but realize I can understand when you look at something as crazy as this. If you look at it as one big thing that you got to do all at once, it's overwhelming. But did you notice we never dealt with the whole thing? We did one baby step at a time. All right? So let's go back to that one that I promised we'd revisit. Let's see. It was in the homework. This is, 4. Technology and I are battling it out today. We've got 14x squared plus 1 minus brackets 8x squared minus 6 close parentheses plus 3 close brackets. Are we all right? I start at the inside. Can I do anything with x squared minus 6?
No.
No. So to get them out of parentheses, I'm going to distribute the 8. So that gives me 8x squared minus 48 plus 3. Now inside those boxed off brackets, is there anything that I can do?
Yeah, negative 48 and 3 can combine.
What do they give me?
Negative 45.
And so now in those brackets, there's nothing I can do. But wait, in front of them, there's a minus sign. So to get them out of the brackets, I'm going to distribute a negative 1. And the rest of the problem is still there. So that the 14x squared plus 1 stays. Then we get minus 8x squared. And then negative times negative is positive.
Yes.
Now do we have any like terms?
Yes.
14x squared minus 8x squared is
6x squared.
squared. Plus 1 plus 45 is plus
46.
Thank you for being patient and let me use that as another example. Does it make more sense now?
Yes.
Yes.
If so, then I think I have to erase it. Well, you know what? Let me see if I go to OneNote. Whoops. Go to OneNote. Yeah, it's still there. So let me erase the pink stuff. What a mess. There's got to be a better way. Does anybody know a better way of getting rid of annotation? I should have erased it before I turned on OneNote. And now let's add a page. And let's look at, we've been looking kind of just at expressions. In addition to expressions, we're going to eventually start looking at equations. And here's the $6 million question. Does anybody know the difference between an expression and an equation?
One you solve and one you simplify.
One you simplify, one you solve. When you look at them, how do you know which is which?
Equation has an equal sign.
Equations contain an equal sign. An equation sets algebraic expressions equal. And we're not going to look at solving equations for a little while. We're going to just kind of lay out a little bit more groundwork. But in the homework, you're going to see problems that involve a formula. And I think everybody's heard of a formula before. Formula is just a special type of equation. It's an equation that states the relationship between variables. And in that homework, you might see some quote unquote application problems that might say something like, given F equals 9/5 C plus 32. Does that formula look familiar to anybody?
Yeah, that was one of the homework problems.
Yeah.
Yeah.
But in real life, has anybody ever seen this one? F is the temperature
Of Fahrenheit
in Fahrenheit.
and C is Celsius.
C is Celsius. I'm misspelling it. How do you spell Celsius? C-E-L-C. Well, we're just,
IUS.
I think it's IUS without the C.
is, okay. Anyways, I can't spell, I can do math. Everybody's got a variable, right? And so let's say, let's find the degree Fahrenheit for 9 degrees Celsius. And so the formula is F equals 9/5 C plus 32. What am I going to do?
Plug in 9
4.
Where C is.
for C.
So that gives me F equals 9/5 times 9 plus 32. And so now we're going to evaluate order of operations. We multiply before we add. So that gives me 81/5 plus 32. And 81/5 is 5 goes into 8 once, 5 goes into 31, 6, 16.2 plus 32. Somebody check my division, please. Does that look okay? And so we get F equals 48.2. And any of the formula type problems that you're going to see in this section are just going to be ones where you substitute and then evaluate.
Professor.
Yeah.
On the homework, it showed it differently. Like it told us to add, like when you needed help, it told us to add the substitute number with the number that was already there, and then do the.
It might have been the different version of the formula. We're always going to follow our order of operations.
Okay.
Okay, on the homework, they might have had C equals 5/9 times F minus 32. And there, because of the parentheses, you would have taken care of what's inside first. You always use
Yeah,
your
that's how they had it set up.
you always use your order of operations. So it's not always this problem, you know, I add first, this problem, I multiply first. We're always going to use the order of operations, okay?
Okay.
At 81/5.
Yeah.
Okay.
And if you take 81 and divide it by 5, check me, I think you get 16.2. And if I'm not mistaken, that's the end of what's in section P1. So let's move on. Let's graduate to section P2. And section P2 deals with our laws for exponents, scientific notation, and radicals. And I know it gets a little bit boring, but we're going to have to start with a little bit of definitions and a little bit of rules before we can actually apply them. If I write B and then I give a little superscript N, is everybody familiar with B is the base? And N is called the, help me out, folks.
Exponent.
Beautiful, exponent. And if N is a natural number, is everybody all right that that's shorthand for just repeated multiplication? It means we're going to multiply N factors of B. So for example, if I took parentheses -2 to the 5th, that means I'm going to take -2, 1, 2, 3, 4, 5 times and multiply. And if I'm not mistaken, I do believe on the first day of class we discussed, or last week one day, we discussed the importance of those parentheses in that expression. And if I take -2 and multiply it by itself 5 times, 5 negative, odd number of negatives is going to make that negative. And then 2, 4, 8, 16, 32. And so I get -32. If you're not real good with that multiplying in your head, is everybody comfortable with how to get an exponent on their personal calculator and how to do it with the parentheses on your personal calculator? We all good?
Yes.
Okay. There's all sorts of things going on in the chat. Does anybody have it open? Do I need to look at the chat, or are there any questions, or no?
No, we're good.
No.
Okay. Then if definition of exponents are all right, we're going to start looking at the laws for exponents. And the first rule that we're going to have for exponents is a product rule. Product means what operation?
Multiplication?
Multiplication. So the product rule is going to hold if I have something like x to the m times x to the n. And I'm positive that some of you are familiar with this rule. But before I go through and write what goes on the other side, for those of you who aren't familiar with it, I'd like to look at an example and look at a little kid approach so that the example makes sense. If I have x to the second times x to the third, what does x to the second mean? That I have two x's that I'm multiplying? What does x to the third mean?
That you're multiplying that number 3 times.
So I've got 3 x's. So if I take 2 x's and multiply it by 3 x's, I'm still just multiplying x's. How many of them are there? 1, 2, 3, 4, 5.
Can't you just multiply 2 and 3 at the top?
I don't think we're multiplying. I don't think 2 times 3 is 5. What do I do?
But you
with
can add it. You can add it.
I add it. And so you see if I multiply 2 x's times 3 x's, it means I've got 2 x's and then 3 more. Does it make sense that if my base is the same, I'm going to add exponents? So if same base, we're going to add exponents. So let's look at a few more examples. If I have x to the third times x to the eighth, same basis, if I multiply 3 x's by 8 x's altogether, how many? There would be 11. Beautiful. What if I have y times y to the fifth? I've got the same base, they're both y's. This one has an exponent of 5. If there's no exponent written, how many of them do I have? How many y's are written here?
6.
Total is 6, but what I'm looking for is everybody all right if there isn't a exponent on the variable, there's an invisible 1? And so my final answer would be y to the 6th. Next example, let's say I have 3 times 3 to the 4th. When we do it with variables, people are usually kind of all right with it. When I start doing it with numbers, people get into making careless mistakes. Is everybody all right? This 3 over here is 3 to the first. So I'm taking 3 to the first times 3 to the 4th. Are my bases the same? If they're the same base, I keep that base. So that gives me 3 to the 5th.
Oh.
The 5th power, if you multiply 3 by itself 5 times, I do believe you're going to get 243. If the bases are the same, they stay the same. So if I have something like 10 to the second times 10 to the third, the bases are both 10, I'm going to keep that base 10. And then I'll add my exponents. 3 plus 2, pardon me, is 5. And so then 1, 2, 3, 4, 5 gives me 100,000. And one more example. This time, if I have parentheses, y squared x to the fourth times parentheses x y to the fifth, and I want to simplify, while there are parentheses here, does everybody see that big picture? It's all multiplication. And when it's all multiplication, because of my associative and commutative rules, I can regroup. So the x's have a like base, I can multiply them, x to the fourth times x. The y's have the same base, I can multiply them, y to the second times y to the fifth. And again, the only reason I can rearrange at will here is because it's all multiplication. And so that gives me final answer, x to the fifth times y to the seventh. Product rule, all right. Do I need to look at anything in the chat, or is that just like people talking to each other in the back of the room?
Yeah.
Just chit chat?
Just,
Okay.
yeah, nothing important.
Nothing important. You guys will let me know if it is something that's, by important, we mean math related, right?
Yeah.
Yeah.
All right. Then if that's the product rule, the next rule we're going to look at is the quotient rule. And when I talk about quotient, what operation is that?
Division.
Division. So quotient rule would be if I have something like x to the m over x to the n. And what's important here is that they have to have the same base. And again, I'd like to do a little kid example to show why this works. So let's say I have x to the sixth over x to the fourth. Is everybody all right? That means I have 6 x's in the numerator.
Mm-hmm.
I have 4 x's in the denominator. And then I can reduce that fraction, can't I? Aren't there some common factors? I can divide out those x's, those x's, those x's, those x's. And what am I left with?
2.
2 x's in the numerator, so I'm left with x squared. And if you're a glutton for punishment, you'll draw them all out. But can anybody see how I could have gotten that result of 2 from the 6 and the 4 without all that work?
Subtracting the 2.
Subtracting the exponents. So it's x to the m minus n. And remember that order is important when you subtract. So it's the exponent of the numerator minus the exponent of the denominator. So, whoops. If I look for some more examples, let's say I have something like z to the 15th over z to the 6th. Bases are the same, so I'll subtract the exponents. Z to the 15 minus 6 would leave us with z to the 9th.
Yes.
What if I have 2 to the 12th over 2 to the 9th? Are the bases the same?
Yes.
So I'm going to keep that base. That becomes 2 to the 12 minus 9, or 2 to the 3rd, which would be 8. So if the bases are numeric, the base stays the same, just like it does with variables. Also, just a little sidebar, penmanship-wise, Z's and 2's can look an awful lot alike. If there's a line through it, it's a Z. No line through it, it's a 2. That quotient rule has 2 little sub-rules. First, let's look at zero exponents. What does it mean if I have something to a 0 power? Well, in order to look at that, I'd like to again kind of go through an example to show you why this works. Let's say, for example, I have something like x to the 3rd over x to the 3rd. My quotient rule tells me that x to the 3 minus 3, which gives me x to the 0. So that would be how we could wrap our minds around the idea of 0 being an exponent. But I want to go back to the original problem, x to the 3rd over x to the 3rd. When I divide something by a 0, what do I get?
Oh, would that be 0?
1. 1. Anything divided by itself is 1.
Oh,
And so anything to the 0 power equals 1. So if I have 3,287,541 x, y, z raised to the 0 power, anything to the 0 power is 1. Unless if I had 3x to the 0. Is everybody all right? This one's a little bit different. Order of operations, we have to take here, because of the parentheses, it's all being raised to the power and it's 1. But here, does everybody see that only the x is being raised to the power?
You'd
So,
multiply,
go ahead.
would you multiply 3 by 1 then?
Yep, you multiply 3 by 1, so there our answer is 3. There is one exception to the rule. The exception to the rule is if I take 0 and raise it to the 0 power. That does not equal 1. 0 to the 0 power is undefined. It has no meaning. If you try to, with your calculator, raise 0 to the 0 power, you would get an error message. That's not defined. Because we don't want to multiply by 0 and end up with an answer that's non-zero. But 0 exponent is always 1, so that one has meaning. But 0 is an exponent, all right. If so, next place we're looking are negative exponents. And so, what does it mean if I have something to a negative power? Well, let's look at that. Look at an example kind of showing how to approach it conceptually, and then we'll come up with a generic rule. Let's say I have something like x to the 3rd over x to the 5th. If I use my rules for exponent, it's top minus bottom, which would give me x to the negative 2. But what does that mean? X to the 3rd says I have 3 x's in the numerator. X to the 5th says I have 5 x's in the denominator. We can reduce this fraction. Doing that, we have just the number 1 in the numerator, and we have an x squared in the denominator. And so, because they started from the same place, we get that to the negative second means 1 over x to the second. And in general, if I have a negative exponent, it means I'm going to get a fraction. It's going to be 1 over the absolute value of that exponent. So, for example, if I have y to the negative third, that means 1 over y to the third. A lot of times we look at this also by putting 1 over as telling us to take the reciprocal. Now, a lot of times with these problems, you see directions that say write with only positive exponents. And so I might have something like x squared, y to the negative third, z. I'm going to go through this one kind of slowly. That's x squared, y to the negative third. And because there's no exponent written on that z, is everybody all right? It's positive 1.
Yes.
The x has a positive exponent, so I can think of that as x squared over 1. The y has a negative exponent, so I can think of that as 1 over y to the third. The z has a positive exponent, so I can think of that as z over 1. And so my final answer would be x squared z over y to the third. With that problem, I did a lot of work to kind of explain why it worked that way. In terms of just comparing this to the final answer, can anybody see, if you wanted to think of it as a shortcut, anything with a positive exponent ends up in the numerator, anything with a negative exponent ends up in the denominator. Slightly different one though. Let's look at x squared over y to the negative third. What's it going to mean when I have a negative exponent in the denominator? We could do all sorts of work to say that, well, that means that I've got x squared over 1 over y to the third. And that would mean, let's see, that means it's x squared divided by 1 over y to the third. And can anybody remember how you multiply fractions? Do the words keep, change, flip, multiply by the reciprocal sound at all familiar?
Yes.
Yeah.
And so my final answer would be x, oh, I'm sorry, I lost the exponent there, x squared y to the third. And so do you notice if I have a negative exponent, the denominator becomes positive when I move it to the numerator? Or I'm taking the reciprocal. The reciprocal of a factor in the denominator, the factor in the numerator. The reciprocal of a factor in the numerator is a factor in the denominator. So, I apologize, I'm looking at my watch because I know I talked too long last class, but we've still got 10 minutes. Let's look at a few more examples. Can I turn the page?
Yeah, you're good.
Good.
So next example, let's look at something like xy squared times x to the negative fourth y to the third. we're multiplying. So the first thing I'm going to do is use my rules for multiplication. That first x has an exponent of 1. Then we have x to the negative 4, y to the second, y to the third, regrouping. Now, over here with these x's, if I'm multiplying, don't I add their exponents?
Yeah.
So what's 1 plus negative 4?
-3.
3. And over here with the y, because I'm multiplying, I'm just going to add their exponents. 2 plus 3 is 5. Now, usually they ask you to just express. Oh, Lord, sorry about that. With positive exponents. And so because that x has a negative exponent, it means I need to make a fraction. The factor with a negative exponent, the exponent will become positive when I move it to the denominator. And the y has a positive exponent, so that's going to go in the numerator. Make sense?
Yes.
Exponents mean we're going to eventually make a fraction out of it. If that's all right, next we have a power rule. And power rule is if I take x to the m and raise it to the nth power. And so, does it help when I do it with number examples to explain why the rule works? If I have x squared, let's say to the third power, doesn't that mean I've got x squared times x squared times x squared, or 2x's times 2x's times 2x's, which would give me 6 altogether. And so if I raise a power to a power, it has that effect of multiplying exponents. So for example, if I have z to the fourth and I raise it to the third power, it means I have 3 groups of 4, or 3 times 4 would give me 12 z's. What if I have x to the negative second to the 5th power? When I raise a power to a power, no matter what the sign is, I'm going to multiply those exponents. -2 times 5 is -10. And then because I have that negative exponent, I need to change to a fraction, and the exponent becomes positive in the denominator. Instead, if I have 2 to the negative second to the negative third, when I raise a power to a power, I multiply those exponents times negative. And then when I evaluate, 2 to the 6th is 64. So if I raise a power to a power, I multiply those exponents. So far, so good?
Yeah.
Wait,
Then-
can you leave that up there for a second?
Sure enough. Let's look at one more rule, and then let's call it a day.
All right, I'm good.
Everybody else good too?
Yeah.
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 Then next thing we're going to do is we're going to look at what happens if I raise a product to a power. So if I have x times y, and it's all being raised to a power, let's say m. When I look at that, because of the parentheses, what's being raised to the power? The x, the y, or both of them?
Both of them.
Both of them. And so I take each factor and raise it to that power. So if I look at an example, first example, let's take 2x to the third and square it. Again, what's being squared? The 2, the x to the third, or both of them?
Both of them.
Both of them. Middle step, I'm going to write out. This one you might be able to do in your head. The 2 is being raised to that power, and the x to the third is being raised to that power. So final answer, 2 to the second would be
4.
4. X to the third to the second. Well, if I'm raising a power to a power, I multiply those exponents and get x to the 6th. And then one more. This is a fun one. If I have x to the third, y to the negative second, z, in parentheses, all being raised to the negative fourth. Everything in those parentheses is being raised to the negative fourth. So I can think of that as x to the third to the negative fourth, y to the negative second to the negative fourth, z to the negative fourth. With me so far?
Yeah.
Now, when I raise a power to a power, I multiply those exponents. X to the negative 12. What would the exponent on y be? What do I get when I take negative 2 times negative 4?
Positive 8.
Positive 8. And then what we have here is just z to the negative 4th. Now, because there are negative exponents, I know I'm going to have to make a fraction. Y has a positive exponent. It will stay positive in the numerator. But anything that has a negative exponent, that negative exponent tells me to make a fraction of it. So I'm going to move it to the denominator, and then the exponent will be positive. What do you think? That one all right?
Yep. Yeah.
All right. Is that enough math for one day?
Yeah.
Yeah.
Okay. I'm going on the assumption, I'm thinking that some of these rules are probably familiar to you, and you probably just need a gentle nudge to your memory. Some of you might not have seen them before, if that's okay, and if you need a little bit of extra time, please either ask your instructor when you do the homework, or send me an email, or read over all of this. Try that homework too, and if you have try the first part of that homework too. What we did not get is we did not get to if the exponent is a fraction. If you start seeing a fractional exponent, or if you start seeing a radical, back away. That's where we're going next class. Does anybody have questions on anything that we did today?
Oh, ma'am.
Okay, I'm going to stop recording.